We're going to be in chapter 4. Chapter 4 is all about triangles. Specifically, we're going to get into lots of properties of triangles and showing triangles are congruent. Once we show that triangles are congruent, that's going to give us a lot of information that we can use for our proofs. So this is going to be another proof-intensive chapter. But after this one, you'll have a lot of tools for doing all the other proofs that we're going to need for the rest of the year. So we're going to start with the real basics. We're just going to be able to classify triangles. You can classify them by two ways. You can look at the angles in a triangle and classify them that way, or you can look at the side lengths in a triangle and classify them by their side lengths. So if we're looking at sides, there are three ways to classify triangles by sides. There's equilateral. If you have three congruent sides, then you have an equilateral triangle. Isosceles means you have at least two congruent sides. So the word at least here means that equilateral triangles are also isosceles. So if we get some properties for isosceles triangles, those will also apply to equilateral triangles, because every equilateral triangle is also isosceles. The last is scalene. Scalene is you have no congruent sides. So let me just show you a few of these. So equilateral, it's going to look something like this. Three congruent sides. Isosceles, I have two congruent sides and one side that's not congruent. And scalene, it's going to look something like that. That would be scalene. So it's important to remember our markings for congruent things. So equilateral, all three of these are the same, so they all get the same marking. Isosceles, I want to mark these the same. I don't want to mark them the same as the mark that I had on my equilateral triangle, though, because I want to make sure that you know that, this is some length. Let's say this is 7 inches. I don't want you to think that this is 7 inches by putting the same mark. Okay, maybe this is 9 inches. So I'm going to put a different mark to show that they're different lengths. So these three are all 7. These two are both 9. And I'm not going to have any markings on my scalene triangle because I don't have any congruencies on there. If we classify them according to angles, we could have an acute triangle. So that means we have 3 acute angles. Something like that. Okay, all my angles are less than 90. We could have equal angular. So that's if I have 3 congruent angles. So if all 3 of my angles are congruent, okay, I would mark them with the same symbol. I can have a right triangle, which means I have 1 right angle. Okay, there's a right triangle. Make sure you mark your angle as right. I can have an obtuse triangle. That means I have an obtuse triangle, or an obtuse angle. So my scalene example from above would be an obtuse triangle. That's not always the case, so don't think that every scalene has to be obtuse. You can have an acute scalene. You can classify them by both. So let's say I have this right triangle here. I can classify it by angles and sides. So by angles, it's a right triangle. By sides, it looks like it's scalene because this side doesn't look to be the same as this one or this one. So this would be a right scalene triangle. Okay, if we look back at my examples I had up here, my isosceles triangle is isosceles by sides. And if I look at the angles, all my angles are less than 90, so it's an isosceles acute triangle, or you could say an acute isosceles triangle. So you can always classify triangles by both sides and angles together, and that's what you're going to be required to do on your homework. Here's some other vocabulary that goes along with them. If you have an isosceles triangle like I have here, the two sides that are congruent, they're called the legs of the triangle, and the side that's not congruent is the base. For a right triangle, you also have legs. Okay, they're the ones that come together to make the right angle. And the side that doesn't touch the right angle is called the hypotenuse. The easy way to remember which legs are on the triangle are to turn your right angle symbol into a little man. His legs are going to touch the legs of your right triangle. If we're just talking about a general triangle and we want to describe its sides in relation to its angles, we're going to use the phrase the side opposite whatever angle. So if I look at B here, this would be the side that's opposite B. Okay, it's the side that's not touching angle B. Okay, here's the side that's opposite angle C. Here's the side that's opposite angle A. So that's another way you can describe sides. I could just as well say this is side BC. This would be side AB. Okay, you can still use the points to describe the sides also. But a lot of your theorems and stuff from this chapter are going to describe it using the opposite terminology. Another way easy to remember is, if you notice, side AB is the side that's opposite C, and there's no C in its name. That word adjacent is going to come in again. We're going to be talking about certain adjacent sides. Adjacent just means that they come together to make a vertex. Okay, or these sides touch. Okay, they touch right here, so they're adjacent. This is going to come to play this chapter, but it's going to make more sense when we get to shapes that have more sides. Okay, now if I talk about adjacent sides, this side here, this red one, would be adjacent to this other red one. It would not be adjacent to the blue one because they're not touching. So here's an example problem. Take a minute, identify what kind of triangle this is by both sides and angles, and then come back and I'll go through it with you. So hit pause, answer the problem, hit play, and you'll see what I do. So if I look by sides, I have these two sides that are the same, so they're congruent. So by sides, it's isosceles. Okay, spelling's important, so make sure you know how to spell these words. By angles, I can see that I've got one obtuse angle, so it's an obtuse isosceles triangle. It usually sounds better if you put the angle in front of the side definition, so obtuse isosceles. That concludes the first section of Chapter 4. You should be able to complete the first worksheet.